This type of problem always comes up when you're talking about quadratic word problems. We're asked to make a quadratic function that models this situation. The company's obviously interested in how much money they can get. I'm not saying they're greedy, but that's kind of the whole point. So the money they get is going to be found by the rate that they charge times, after reading, I think we're left to assume that every family has the same amount of hours. They haven't told us that they differ. So the money that they make is going to be the rate that they charge per hour times the number of families, or customers in this case. Okay, we'll just assume they all have a 4-hour cleaning session or something like that. So obviously more rate, more families, more money. But maybe we could increase the rate at the cost of losing some families because it becomes too costly. But maybe that could help maximize our revenue. Or maybe we should reduce the rate so we can get more customers, and that would maximize our money. But this is the basic structure. It's a simple idea that the amount of money you have is found by taking the rate times the amount of customers you have. So the rate starts off at $10.50. And at that rate, I'm leaving some space in those parentheses because we can add some stuff here. At that rate, they said we have 50 customers. But they said we could increase the price by 20 cents, in other words, $0.2, at a cost of losing 2 customers. Or we might just do it twice. We might increase the price by 40 cents and we lose 4 customers. Or 60 cents, then we lose 6 customers. So we're going to attach a variable here where x represents the number of times we increase the price by that 20 cents. And now that's something we can maximize. We can find out how many times we should increase, or perhaps if it's x is negative, how many times we should decrease the price. But this is a quadratic to model the situation. It's just not in standard form. To put it in standard form, you would just multiply these two parentheses. So multiply $10.50 times 50 and $10.50 times negative 2x. And then we got to make sure we multiply this guy to everything in the other parentheses. 0.2x times 50 and 0.2x times negative 2x. And so standard form of a quadratic, we usually write it in descending powers. So we'll say this is negative 0.4x squared. It's minus 11x plus 525. So that's part A. Part B wants us to state the domain and the range of the function. So the domain is all the values you can plug into the function. And in this function, x represents the number of times we increase the price. So we're pretty much free to increase or decrease the price however much we want, except we don't want to start having negative families. We could have at most 0 families. So that means x equals 25 is like a peak. We can't have x go past 25. But likewise, we can't give people money. That wouldn't make any sense for us. So we also want to restrict our domain on that side as well. We don't want to go $10.50 plus 0.2x. This is our rate. We don't want our rate to be less than 0. We want it to be greater than 0. So we can set up this inequality and solve it just to get x by itself like we normally do. And divide both sides by 0.2x. Divide both sides by 0.2. So in order to make sure our rate never goes past 0, x has to be greater than negative 52.5. So our domain for this function we found is it can go, we don't want it to be exactly 0, so I'm going to use parentheses. Negative 52.5 to 25 is our domain. So we got our domain. The range of a function are all the values that can come out of a function. And so since this function represents how much money they make, the only elements we're interested in are from $0 to really whatever the maximum value is, when we have not found out the max amount of money that they made yet. Then we're going to find that out in another step. But just remember that range represents all the x values that you can plug into the function that makes sense, and we found these by making sure that we didn't have anything that was like negative dollars or anything like that. The range are all the values that can come out. We can make it $0. We could just break even, or we could reach some sort of maximum, which we're going to find in this next step. So they want to know what hourly rate maximizes their income. So since this function represents how much money they're going to make, maximizing this function will maximize their income. And you maximize a quadratic. Well, first, it's a quadratic that's shaped like this. kind of like a lowercase n, because a, the coefficient of the variable being squared, is negative. So it'll make a u if the coefficient is positive, but since a is negative, it's going to make a parabola, something like that. And so if we can find the vertex, the peak of that parabola, that's going to tell us the maximum value. And you find out the x-coordinate of a vertex by using x equals negative b divided by 2a. In this case, our b is a negative 11, so negative 11 makes a positive 11. And we got 2 times our a of negative 0.4. So we're at negative 13.75. That is the x-coordinate of the vertex. So that's going to tell us where the maximum occurs. So that answers part B here. What's the hourly rate? That's x represents, well, actually, sorry, that helps us answer the question. That doesn't fully answer it. X represented how many times we should increase the price by 20 cents. So the hourly rate we had by this expression here. Oh, sorry. The hourly rate is $10.50 plus 0.2 times whatever that x is. So to find out exactly what that hourly rate is, we have to plug in that negative 13.75. And when you simplify this, you get 7.75. So it looks like our function told us we're going to maximize our revenue if we charge $7.75. So what's their maximum possible income? The function that we have, this function tells us how much income they're going to make. And we just found out where we maximize income if we charge $7.75. Or in other words, if x, our increment variable, was, what did we say, 13.7? We said it was negative 13.75. So we'll plug that in for x everywhere where we see an x. So just be careful with the calculator here. Oops, and this is supposed to be squared, but be careful that you do this squared and then multiply it by negative 0.4. And then you got a negative 11 times a negative, that should be a positive there too. So combining those, about $600 and then 62.5, so 62 or 63 cents depending on how you want to round. That's the maximum amount of revenue we can see.